A warm welcome you all. Today we are discussing about overvoltages due to switching surges. Presented by Professor M. Jivin, Department of Electrical and Electronics Engineering, Rohini College of Engineering Technology. Switching overvoltages. Switching surges have become the governing factor in the design of insulation for extra high voltage and ultra high voltage systems. In the meantime, lightning overvoltage come as a secondary factor in this network for two reasons. The one is overvoltages produced on transmission line by lightning strokes are only slightly dependent on the power system voltage. As a result, their magnitude relative to the system peak voltage decreases as the latter is increased. External insulation has its lowest breakdown strength under surges whose fronts fall in the range of 50 to 500 microsecond, which is typical for switching surges. Origin of switching overvoltages. Energization of transmission lines and cables, especially energization of a line that is open circuited at the far end. Energization of a line that is terminated by an unloaded transformer. Energization of a line through the low voltage side of a transformer. Re-energization of a line, especially when high speed reclosure are used. Origin of switching overvoltages. Load rejection, fault initiation and clearing, switching on and off of equipment, particularly switching of high voltage reactor, switching of transformer that are loaded by a reactor on their tertiary winding. Temporary overvoltages. They last for long durations, typically from a few cycles to a few seconds. They take the form of undamped or slightly damped oscillations at a frequency equal or close to the power frequency. Some of the most important origins are load rejection, Ferranti effect, ground fault. Then overvoltage protection. The adverse effect of overvoltages on power network can be reduced in two ways. What are the ways? By using protective device, that is surge arrestor, reducing their magnitudes wherever the surge originates, that is overvoltage control. Control of switching surges, resistor switching, phase controlled closure, use of shunt reactor, drainage of trapped charges. These four things are the control of switching surges. First one is resistor switching. At the figure shows source and resistor and a switch. At the time of energization, the main breaker is open. While the auxiliary breaker closes, the voltage impressed at the line entrance is thus VE equal to E of T into Z0 divided by R plus Z0. The value of resistance R in general depends on a large number of factors as follows. The value of R is selected to achieve optimum result for the system. The surge impedance of connected lines when there is single line or multiple lines. The insertion time of the resistance control the overvoltages normally off cycle. The value of resistance is slightly bigger than the surge impedance of a single line which is switched, normally 400 ohm. The next one is phase control closure. By properly timing of the closing of the circuit breaker poles, the resulting switching overvoltage can be greatly reduced. Controlled switching phase should successfully for the three poles to accomplish a reduction in the initial voltage on all three phases. This is extremely difficult with conventional circuit breaker, but is quite possible with solid state circuit breakers. The next one is use of shunt reactors. Shunt reactors are used on many high voltage transmission line as a means of shunt compensation to improve the performance of the line, which would otherwise draw large capacity current from the supply, they have the additional advantage of reducing energization surge magnitudes. This accomplished mainly by the reduction reduction in temporary overvoltages. The last one is drainage of trapped charges. Charges are trapped on the capacitance to ground of transmission line after their sudden re-energization. If the line is re-energized soon after, usually by means of automatic reclosures, these charges may cause an increase in the resulting surges. Last one is control of temporary overvoltages. How to be control temporary overvoltage? As seen in the above equation, the voltage can be reduced by increasing capacitive reactance. A shunt reactor of reactance XR is added to the transmission line. The equivalent input reactance of that line will be increased from XC to XC dash. The equation will be XC dash equal to XC divided by 1 minus XC divided by XR. This is the overvoltage due to switching surges. Thank you.